The electrical and instrument control system online and actual training. Right here, I'm gonna discuss about the oil and gas separation. The oil and gas separation through this horizontal vessel. This drawing, we call it is P&ID, or piping and instrument diagram. As you can see on the diagram, there are a lot of different type of instrument components, which is this one is LT, or a level transmitter, and this side is LV. This is the level valve. This is level transmitter, pressure valve, and then uh, pressure transmitter. And this is also the level controller, and this is the level controller, and this is the pressure controller. So let us discuss a brief explanation of this horizontal vessel, or in this P&ID drawing. So this is the inlet, three-phase inlet. This is inlet with content of hydrocarbon. Means hydrocarbon is hydrogen carbon. So meaning the hydrocarbon with content of oil and gas. So the oil and gas it's peeling on this horizontal vessel. So this is now how will separate the oil and gas. Inside, once the hydrocarbon comes to this vessel, the gas evaporation it comes to up, comes this side, and then the oil it comes this side. So there is a division in between of the uh, in the vessel, in between of the oil and water, because the hydrocarbon will contain oil and water. So it also separate the water and oil in this vessel, and this is the gas. As you can see here, this is water outlet, and this is oil outlet, and this is vapor outlet, which is already separated by this uh, vessel separator, vessel oil and gas separator. So aside from this, this is the point idea. This is what I discussed. It's a brief explanation of oil and gas separation. So we are talking about our instrumentation. So here I made a black diagram. As you can see here, this is the vessel oil and gas separator, and around this oil and gas separator, there are a lots of transmitter monitoring of this vessel. Like there is a level transmitter. This is the level transmitter. So also this is level transmitter, and this is the one instrument component monitoring the level of this vessel. There is also the LCV, or control valve, and also here control valve, and here there is also PCV, or pressure control valve, based on this uh, piping and instrument diagram. So right now, this is our instrument. This LCV is taking liquid from the vessel, downside of the vessel. It's going to the water outlet. This water is also going for the processing facilities, like produce water. And also here, also this one, this liquid, this is oil. It's also going to the oil uh, facilities, as well as uh, the gas. This gas outlet is coming here, gas outlet through the control valve. And then now I'm talking about the um, piping connection of the valve. From this side, this is piping, comes to the PMV, or piping manual valve, comes to PMV, so that anytime for the maintenance, we can isolate the process lines by this PMV if we have like maintenance of this control valve. So also this one, this lever transmitter. Lever transmitter, normally connection from the vessel, it should be stainless tube. This should be stainless tube, and also this one, the IMV, or instrument manual valve. As you can see here, from the vessel going to the IMV, or instrument manual valve, comes to the manifold of the transmitter. Then from the downside, this is low pressure. This side, this is low pressure, and this is high pressure. This from the vessel comes to the IMV valve, going to the manifold valve at the high pressure side. The same also here, and also this one. Uh, this pressure transmitter. This pressure transmitter, it is monitoring the pressure of this vessel, and then there is also a PCB. This PCB is controlling also the pressure gas outlet, as well as also this oil liquid oil outlet. So see, as you can see here, this is the controller. We're talking about the connection between label transmitter and the label control valve. So there should be a relation between of these two transmitter. As you can see here, the signal, the label controller, then the signal is going to the DCS. Signals. Transmitter, this is analog input signal. The transmitter from the signal is from transmitter to DCS. LCD is analog output. The signal from DCS to LCD, because transmitter signals from transmitter to DCS, because the label of this vessel is taken by the label transmitter and then sending to the DCS. So DCS always monitoring of the label of this transmitter. So and also this one, this label transmitter signal is from DCS to LCD, because if the DCS found out that the vessel is already empty. So if it's already empty, then the DCS will send analog output signal to the valve to close the valve, because the vessel is already empty. The same also the principle here. Once there is no liquid inside the vessel, by sending signal of this transmitter, then DCS send analog input signal to the LCB to close the valve. As well as here, if the pressure transmitter, if no more pressure of this vessel, then the pressure sending to the DCS that the vessel is empty of pressure, then the DCS sending analog input to the valve to close this valve. Okay, that is the brief explanation of the oil and gas separation.